Hi everyone, let's solve today's Leetcode problem, which is problem number 61, rotate list. Okay, it's a medium problem. Given the head of a linked list, rotate the list to the right by k places. Okay, so if you see this example, this is our given linked list, and we have to rotate this linked list by k positions in the rightwards. So if we rotate by 1, so in this example, k is 2. Okay, so if we rotate this by 1 place, so from here the 5 will come to the front side. Okay, and this node will be broken and this will be attached to here. Okay, so this is after the first rotation. Now if we do the second rotation, so this node will be breaking and it will going to attach to the this one. So you see 4 is here, 5, and then so on, and after 3 this is null. Okay, so similarly above also. So yeah, this is what the problem is saying, that we have to rotate the list to right by k places. And if you see the constraint, number of nodes will be from 0 to 500, but if you see the k value, k can be up to 2 into 10 to the power 9, right? So yeah, this is what the constraint is. As part of this problem, we are going to cover two approaches. One is brute force, another is optimal. Okay, so before starting any approach, we know that if we have given this linked list, let's say of length 3, okay, and if we do rotation that is greater than this value 3, so we will get the same linked list, right? For example, if this one, if we do one rotation, so linked list would be something like 3 1 2. Okay, so this is after first rotation. Now after second rotation, so it will be uh, 2 3 and then 1. Now on the third rotation we will get this 1 2 and 3, which is similar to the first one. This and this are same, right? So if there is any rotation that our given value k that is greater than or equal to n, which means we will receive the same rotation among these only. If let's say here it would have been k, would in this case, let's say k we would try is let's say 7, so we will just keep on cycling over these only. Okay, now after this again this will come. Okay, next one will be whatever, it will be same as this, then whatever next one it will be same as this, and so on. We will just keep on doing, right? So that for that reason we will do this k mod n. Okay, so we will just do whatever is only that many times of rotation that is less than n. Reason being, we will get the right value because it repeats the same rotation, right? So that is one key observation that we are going to follow in all these approaches. Now let's see what we are going to do in this brute force. So we will start this iteration from here and we will reach till the end. Okay, there is no next value is not null, next value is not null, next value is null here. Okay, so this next value is null, so we'll break from here. And what we will do, we will attach, we reach this end, this is an end node, right? Now we will attach this next node here to the front. Okay, and then we will break this node. Okay, so this is we did, and after this is how the rotated linked list would look like, and this is after the first rotation. This we will again rotate it. Okay, so we will start with this, then we move this. Now here at 4 we came, this is the last node. Okay, because next points to the null. So what we will do, we'll attach this point to the first one. Okay, every time we will if we reach the end node, we will attach this to the first one and we will break this node. So how it will look like is like this. After second rotation, 4 comes here, 5 1 and 2. So what we actually did, for every time we reach the end node, and after end node we attach the last node to the first node, and then that is our one rotation, and we repeated this for k times, right? So this is what we are going to do, and k is definitely done mod by n, so we won't do more than this many times. So what would be the time complexity for this approach? So we are doing this every time we have to reach end, so it will be n times we need to reach the end, so that is the length. And so k times we are reaching end and attaching end node to the first node, so it is n into k. And space complexity, we are not taking anything additional, so it is O of 1. Okay, so yeah, that is about the space and time complexity for this approach. Now let's solve this optimally. So if you notice that we have to do k rotations. Okay, and here let's say k was 2. Okay, now since this is linked list, we know that if we attach, these are all linked, right? So if we have to remove, what is this k rotation means, that these two will get attached to the first side. Okay, and this will point to null after the k rotation. And we know this is k nodes that we are going to attach to the front side. And in total, if this was n nodes, okay, n nodes, then what will this be? This will be n minus k nodes, right? So if we find the list count of nodes, and then if we just move our pointer till here, and after then when our pointer is here, what we can do, we can store this as our new head, and we can attach we can put this as null because this is the end of the node, and then we will able to achieve this, right? So I'll tell you step by step what we are doing. First is we are going through and we will calculate the length. Okay. So we went through, we calculated the length. Okay, it's 5. So here the next value is null. We will stop here. Okay. So from here we got the length as 5. Now we will point this node to the front side. Okay. Now this is all attached and this was our head. Now we need to do this thing also, k mod n, with the same reason as I stated above, and we need to do this pointer, we have to move these many times, right? In order to rotate k times, you have to move these many times because this will be our new head, right? So this will be our new k, length minus k. Okay, now we will move this pointer k times. Okay, so we move this one time. So here when it came, it is one time and then two time. After two time, we see that we can store this as in our new head. This will be our new head. So we'll store this, and this one we will point to null. Okay, and at the end we can store this as our head value. Okay, so this will how it will look like, and at the end we will receive something like this. So yeah, this is about this approach. So let's write the code for this. So this is the edge case that we need to check first in case of linked list tray or whatever. So head should be not equal to null. Okay. If it is null, then we can directly return the head, or head next should also be not equal to null. Okay. Because if head next is null, which means there is only one element. So after any rotation, it will remain same. Okay. Or k is equal to 0, which means we don't need to do any rotation. Okay. So in these cases, we can directly return the head. Okay. This is our base case. Now we will keep another pointer to go over the linked list. So that will be nothing but list node star current equal to head, which will store the head node. This is to iterate over and get the length. Now we will get the store the length. Okay, length is equal to 1 initially, because what how we were checking was we started from here and we were checking if it has next value or not. So this is one count. Here it if it has next value or not, count is 2. Here we were now we came here, now we were checking if it has next value or not. So next it is not there, it is null, right? So we will break from here, right? So we came here one time, two time, right? So here length is 2 only, but here we didn't consider this one, right? So for that reason we will start with length as 1 only. Okay, now while current next is there. Okay, so what we will do, yeah, so we will move our current to next pointer. Okay, and after that we will also increase the length of the this linked list. We are counting this length basically. Then we are done with this where we have calculated the length. Now since we calculated, now we our node is current pointer is pointing here, we can now attach this to front. Okay, so what we will do, current next is equal to head. Okay, now we also need to do this k is equal to k mod length that we have stored, right? And our new k would be nothing but length minus k, because we need to move our pointer just the k times for having this k rotation. So k rotation, length minus k time we have to move our pointer. Okay, now it's nothing, now we have to just move our pointer k times. So while k is greater than 0, so we'll move our current pointer, currents next, and k minus minus. Okay, at the end where our pointer is, let's say somewhere here. So now what we can do is this next value would be our new head, right? So we will do the same. So head would be current next, and current next would be null. Basically, we are breaking this node, so we are moving, having this next as null and storing this as our head. Okay. Now at the end, we are done with this. We can return head. It stores the new head after the rotation, key rotation. Okay. So yeah, that's about this. And now let's discuss the space and time complexity. So here we are calculating the length, which will go n times. Then this is another loop which goes basically length minus, that is n minus k times. So altogether it is O of n plus O of n minus k, which is nothing but k mod n. Okay, not the bigger n value. So altogether nothing but O of n only. And space complexity is O of 1. Okay. So yeah, that is about the space and time complexity for this approach. That's all for this video. I'll attach the GitHub uh, link in the description below. Thank you for watching. Have a nice day.